The purpose of this little tutorial is to show you how to do some basic stats in SPSS. I called the library today and they said you have access to the program in the library. If you go there and you find that to not be true, make an appointment to meet with me to run your stats if you need to. So we're starting with a data set that one of your classmates helped to compile at Shriners Hospital, and this represents some dietary data from 9 children who are burn patients at Shriners. And so we have a number of variables here. There's their total burn surface area, their age. We have 2 weights for them. And this dietary data comes from 2 3-day food records that were taken about 6 weeks apart. And this isn't optimal, but I did it for the purposes of demonstration. In columns J, K, and L, you can see that I calculated mean total protein for those 3 days on average, so it's a daily average. Mean protein coming from supplements. So they have a number of different boost and shake supplements that they can take. And then in the L column, I calculated the proportion of protein coming from a supplement versus the food they're eating. And so this is up until column L, that's data from the first 3-day food record, and then columns M through the end of the spreadsheet are the same data for the second 3-day period that the kids recorded their food intake or their parents helped them record food intake for. So that's the data we're working with. We're interested in questions surrounding protein intake between these 2 dietary records 6 weeks apart in kids with severe burns. And so this is after they've been released from the hospital, and then they're in an outpatient program for a period of months after their initial treatment. So here I'm just going to show you how to run some, first open your data. So when you get to, after you have your data compiled, wherever you get it from, and you have it all set up in Excel, you will want to import your data into SPSS. That's the easiest way to do it rather than cutting and pasting, because your variables will be in there too. So be sure when you're creating your variables in Excel to not have anything on the top of the spreadsheet except for the variable name in line 1 in Excel. And then you have your data below, and don't put any units or anything in your columns. You just want numbers. So once you have your spreadsheet all compiled, you can open it in SPSS. So you just go to Open and then Data, and then that window will pop. And you are going to choose a file type of Excel. It's going to default to SPSS, but you won't have that, so choose Excel. And then find your Excel sheet, whether you've downloaded it to the computer or you have it on a jump drive, the same way you'd find any file. Then next it will give you this prompt. It will ask you if you want to read the variable names in the first row of data. You will have set your spreadsheet up so that that works, and that saves you a lot of time. So it'll already check yes, but you're going to keep it that way. And if you've done everything right, then when you open your data after that, it's going to look, as you can see it here, in the columns, you'll have your same variable names in the columns already there for you. Then at that point, we can look at our descriptive stats. So we're going to be interested in some means and standard deviations. We just want to get that for some of our variables. So if you have a table, say you looked at a group of patients, a lot of times you'll see in papers their mean BMI, height, weight, blah, blah, blah. So you get that mean plus standard deviation by doing the descriptive statistics first. So here I've just highlighted, this is the box that pops up after you select descriptives, and I've just highlighted some things that I want to see the means for. So you can select multiple variables at once by holding the control button and just hitting the ones, and then they'll be highlighted. Once you've selected, or you can do them one at a time, doesn't matter. Once you've highlighted what you want, you just hit the little arrow going to the right, and that'll put it in the variable, and then it'll give you output descriptive data for those variables that you select. So it'll it'll pop up a new output window and it looks like this. And here you can see it gives you a range with the minimum, well, the minimum maximum numbers and then the means in the fifth column over. So for example, our kids are, like a little over, a little under 13 years old, 12 years old on average, plus or minus 3 years. Uh, their weight is 41.5 or 6 kg, plus or minus about 10. So it just gives you all this data. Now, when you're building tables on your posters, don't include all these decimal places because these aren't important, right? Because whatever machine we use to measure their weight couldn't go down that far. It probably just read 41.6 for a given person. So you should check your significant digits and don't include ridiculous decimals on your poster. So the next real stats test, and this, I don't know what questions you all have, but here's some basic tests that will probably give you some kind of preliminary answer for whatever question you're asking. So the first test we'll go over is a one sample t-test. And this kind of test compares a mean value of your data to some known quantity. So typically with the one sample t-test, that's the known mean of the population. Here, we're more interested in nutritionists about, meeting a recommendation or something like that. So that's what I'm using the one sample t-test for here. We're going to see whether the kids have met a protein recommendation using a one sample t-test. So for you, if if you're looking at some variable like calcium and you want to know whether people are meeting the RDA for calcium, the standard that you compare the mean of your information to will be the RDA for calcium. So I just pulled from a paper, to find what standard I wanted to use. I pulled from this paper about 2 grams per kg is maybe what you'd want a burn patient to have minimum. So my question is the recorded protein intake different from the recommendation of 2 grams per kg? On average, does the protein, so i.e., does the protein intake meet the recommendation? So that's kind of what I want to know. So in this, what this test is going to do, it's going to say, is the mean value in this group different from, we'll designate it as 2. So is it different from 2? So if the answer is no, it's not different from 2, so we don't get any significant difference, that actually probably means that they're meeting the recommendation of 2. If it is significantly different, but the mean is higher than 2, then we are also meeting the recommendation. They're just above it. And then if the mean is lower than 2 and there's a significant difference, then they're not meeting the recommendation. So for example, if the mean is 1.2 and we have a p-value of 0.003, then we know that the kids are not meeting their protein recommendation. So to run this test, we're going to go to Analyze, Compare Means, and then select a one sample t-test. So here's the window that will pop up when you select a one sample t-test, and this variable is the measure of the grams per kg. So I just took their average protein intake for the first time, diet record, divided it by their weight in kg, and that's a variable. So I selected that one, and down there in test value I put 2 for 2 grams per kg. So after you have this all entered, you just hit OK. And then after you hit OK, in the output window, you're going to have your t-test show up. It may take a second to populate, but it'll be there eventually. And here I've just circled the mean value, which is 3.29, so that's higher than 2, right? And then we look at our significance value here for a two-tailed test, and it's showing 0.015. So for most statistics, normal statistics, you're looking for a p-value or a significance of less than 0.05. So in this case, it appears, if we had gone through all, made sure all the assumptions were correct and everything, that this is, a significantly different number from 2 that we have here. So there you have it. So ideally, you make sure that all the assumptions for a t-test apply before running it. So I just want to make you aware that we didn't do that. If you aren't familiar with the t-tests and haven't learned much about them in the past, it would be good for you to read about them so you understand more what they are. So this website here has some pretty good tutorials. And it shows you how to go through point and click through SPSS also. And you can just learn more about the different tests that I'm talking about and the assumptions associated with them. Now we're going to go into a 2-sample t-test. If you use a 2-sample t-test when you want to compare 2 means to each other and see if they're different or not. So if you're looking at 2 independent groups and it's independent data, then you use an independent samples t-test. If they are not independent or they're dependent on each other, then we run a paired samples t-test. We have these food records, as I mentioned before. We followed the same burn patients. So we did a diet record right after they were released from the hospital and then about 6 weeks later. So we want to know if their overall, the questions we'll ask with a t-test are if their overall protein intake differed between these 2 diet records, or if the proportion of protein coming from the supplement differed between these 2 time periods, because typically the physician will give a high protein supplement prescription at the beginning and then kind of lay off that after a while. So essentially, we need to compare the mean total protein and the mean proportions between the 2 different time periods where we took the diet records. Given that information, do you think that these samples are independent or dependent? And do you think we're going to run an independent test or a paired samples test? That's right, they're dependent. We're going to run a paired samples test. Okay, so to run this test, you hit Analyze, Compare Means, and then Paired Samples t-test. So that's what it looks like. And then here, you have to define what your pairs are. So what we did here is we took, for the first pair, we're looking at the ratio of the protein coming from supplements. So that's just the grams of supplement protein over grams of total protein. So it's a variable that describes that. And in variable 1, pair 1 slot, so in the top left, we've got that variable from the first data collection, first diet record, and then in variable 2, pair 1 slot on the top right, we have it from the second period where the diet record was taken 6 weeks later. So those 2 are associated with each other. They're a pair because we're looking at the same patients and it's the same variable taken in the same patients just 6 weeks apart. So they're related to each other. And so we do the same thing, finding the mean total protein. So I've already added it for the first diet record period, but then you see here highlighted in the whole variable list is the mean total protein. That's from the second data collection period. And I'm going to put that in the pair 2, variable 2, bottom right hand area to define that pair. And what the test actually does when it runs a test, since these are dependent samples, is it calculates the difference between your variables that are in a pair, and then it compares that difference value to 0 and tries to see if it's different from 0 when it runs the test. And it actually does the same thing in the 1-sample test. So in a 1-sample test, it subtracts your mean value from the value you define. So that would have been 3 point something, whatever it was for our last example, subtracting 2 from that, and then seeing if that number left over is different from 0. That's what a 1-sample t-test does. And a paired samples t-test basically creates a 1-sample t-test by subtracting the paired samples from each other, the mean of the paired samples, and then kind of defines the difference and compares that difference to 0. If the difference between the variable pair is not different from 0, then you have no difference in that variable over time. If there is a difference from 0, then there is a change in that variable over time. So here's our output. It pops up right after all your other output. And here we see our means. If you look up on top here, our pair 1 means for the ratio of the protein coming from supplement. And right when they were released from the hospital, that was about 0.2, so about 21% of their protein was coming from supplements. After 6 weeks, it was roughly 16% of protein coming from supplements. And what we're asking this test to do is to take a difference between 20% and roughly 16% and say, is that 4% based on the variability in the sample, blah, 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 is that different from 0? Does it mean anything? And the same thing for our second pair here. We have about 129 total grams of protein intake, 132 total grams of protein intake after 6 weeks. So we want to know if 129 is different from 132. So the program takes the difference of those two, comes up with, you can see on the bottom in the under the mean that the difference between those two is negative 2.965, blah, blah, blah. So we're asking if that 3-gram difference is important and significant. So we have our mean values here. You know, at a quick glance, they really don't look like important differences. But we kind of define that. Let's see. We kind of so what it does, what the test does, is it compares this mean here that you're looking at on the bottom with paired samples test being the bold heading. Look at the mean column. Are those numbers different from 0, given the information in our samples? And so you can go over to the significance over here, and we're looking for something less than 0.05. These are obviously way above 0.05, so there's no difference in these variables between the first and second diet collection, which were collected about 6 weeks apart. So their ratio of supplements coming from protein was about the same, maybe despite some different recommendations from the doctor, and their total protein intake didn't really differ over time, so it remained about steady as far as we can tell from this test. Just like the one sample test, there are assumptions associated with running a dependent t-test as well. So go to this link and read up more to learn about those assumptions and all the assumptions you should also test when running a t-test. So the last thing we're going to talk about is a correlation. A bivariate correlation gives you information about whether two variables are related to each other. So what we're going to ask here is we want to know if the age of a child is just associated with the proportion of protein provided by a supplement. Maybe, you know, younger kids have an easier time drinking the supplement compared with the older, you know, teenagers who are going through puberty and eat no matter what. Who knows? So that's what we're going to ask, if these things are related to each other at all. So we could go to Analyze, Correlate, and then select Bivariate. And then this screen pops up. So you'll put the two variables that you want to compare to each other in the variables list. So you just move them over. Select Pearson. Here, if you wanted to define whether you expected the relationship to be a positive relationship or a negative relationship, you could do that. We don't really have any clue, so we're just going to, if you don't know what direction you expect the relationship to be in, you just select two-tailed. So we're going to do that. And then the output you get looks like this, and you can see that the correlation is 0.066, negative 0.066. That's basically nothing. That is very close to 0. For something to be, it depends on what data you have in your sample, but, you know, correlations that are stronger, maybe like 0.65 and above, or negative 0.65 are look a little more important, but then you still have to go to the stats to know if they're significant or not. So again, we're looking for a p-value or significance of less than 0.05. So here we can see that there is absolutely no relationship apparently between the age of the child and the grams of protein that they get from a supplement versus food. Okay, that's it. Um, this is just like a really quick overview of how to run a couple of basic stats in SPSS. We called the library today. You're supposed to have access to it in the library. If not, feel free to make an appointment with me, and I will walk you through it in my office. It'll take a couple minutes as long as you have your data prepared. Prepare your data first, get it in the right format, and then bring it on a flash drive, and we can run the stats really quick in my office if you want. Uh, if you think that your question can't be generally, you can't run some preliminary stats to answer your question, then contact me too so we can see if there's something else you need to run and I can help you with that. Okay. Have fun with your statistics.